That's how my sister is.
Yeah.
She does that for like 5 minutes.
It was awful. I was like, I don't know how this happened.
Okay, so we're going to talk about parametric equations today. Okay, this is something you've never seen. Okay, which I think is exciting. Okay, first semester we did a lot of stuff. You're like, okay, this is like old things in this moment, but this is like brand new. Okay, so a set of parametric equations is more than one equation. Okay, we have, and I don't care how much of this you write down, as long as you write down this right here. Okay, this would be important. So we have a function. Well, we have two functions in terms of a third variable. So usually we have like y and x together in the same equation. Well, now we have two equations, x equals and y equals, where they're in terms of a third variable. Typically we're going to see t. We call them parametric equations because t is our parameter. Okay, so what these are going to look like, there it is. What these are going to look like is, okay, so this is what we call a rectangular equation. Okay, that's what we're used to seeing, right? Y equals some sort of function of x, okay? So we're going to call that rectangular. Here would be a set of parametric equations that would create this one rectangular equation. And this would be its graph. Everyone just take a time out from writing. What's different about that graph? It starts and ends.
There's like arrows.
There's like weird arrows here. Okay? Parametric equations have direction. As we get bigger with t, we follow the curve, and it has direction. So we're going to draw those arrows. As t gets bigger, what happens to your curve? Go ahead and write down what you need to. That's going to be the biggest difference in our graphs, is we're going to have direction with our curves. You don't have to write this down, okay? This is like the example that's in your book with the definition. I just put it all up there together for you to see. But I wanted you to see the graph that it's going to have, like those directed arrows, so we know where the curve is being drawn. So what actually is happening in this graph, when t is 0, we're right here. And then when t is 1, 2, 3, 4, 5, 6, 7, 8, this is where it would, that's how we would get all of these points. And then we just draw an arrow to tell us what direction our curve is going. Okay. So we're going to talk about the graph part of it first, so we can kind of get our minds wrapped around the graph. And then we'll talk about how we go from a parametric equation to a rectangular equation. So really we're going to do two things today. We're going to graph these guys, and we're going to take parametric equations and squish them down to one rectangular equation, so we know what that graph should look like. Okay, so let's just start with some basics. What I'd like you to go ahead and do is write down this set of parametric equations. X equals t squared minus 4 and y equals t over 2. Okay? And then I've given you that I want this curve to be graphed only from negative 2 to 3. So what we're going to do to graph this, especially since we have this interval, is I'm going to ask that instead of an XY table, you're going to make an XYT table. If T is this, what is X, what is Y? If T is this, what is X, what is Y? So you're going to make a T XY table. We're going to plot our points, and then we're going to connect them and indicate the orientation. We have to draw the arrows based on how we plotted our points. So we're going to begin with t equals negative 2 because that's what it's telling us to do. Okay? Well, if t is negative 2, what is x? And what is y? If t is negative 2, what is y? Okay. Then we're going to keep going. If t is negative 1, if we plug negative 1 in, what would we get for x? And what would we get for y? One here. Okay. We're just going to keep doing that until we get to t equals 3. So next up, 0. What do we get for x? Negative 4. And for y, if we plug 0 in for t. If we plug in t equals 1, x is t squared minus 4 would give us negative 3. Y equals t over 2 would give us 1/2. We plug in 2, t squared minus 4 would give us, and t over 2 would give us 1. And our last one, t squared minus 4, if t is 3, that would give us 5. And 3/2. Okay, so now we're going to plot these points. And we need to plot these in order from t is smallest to greatest and pay attention to where these fall. So first we have 0, negative 1. Then we have negative 3, 1/2. Then we have negative 4, 0. Then we had negative 3, 1/2. Then 0, 1. Then 5, 3/2. Okay? So if I start with where I plotted my first point, this is how we would connect them all together. So I would need to indicate our orientation. We started here and ended here. So I'm going to draw a couple arrows so I can see the path that we followed. What's nice about parametric equations is we can separate out the horizontal movement from the vertical movement. And what we can do with this in calculus is we can talk about vertical speed versus horizontal speed and all sorts of other kind of stuff. How the horizontal is changing, how the vertical is changing. But it's nice to be able to separate out the horizontal movement from the vertical movement. So horizontally, this is how our particle is moving. Vertically, this is how our particle is moving. Okay? Together, we create this path right here. Okay? Now, do you think your calculator is going to be able to graph these? Get your calculator out. I want to show you something. Okay, so the first thing you would need to do is you would need to go into mode. And do you see where it says function? There's a mode called parametric. Yes, it might be parametric or it might be PAR. Okay, if you highlight that and hit enter and then quit out of it, when you go to y equals, you have t's. Okay, x equals and y equals. Okay, so you're still going to use this button right here, but everybody press it with me. Instead of an x, a t is going to appear because you're in parametric mode. When you want to go back to x's and y's, then you go back to function mode. Okay, but if we were to plug this in, let's see, t squared minus 4 and t over 2. And then hit graph. Oh, that went too fast. Watch your graph though, because it's going to graph it in the orientation that we would expect. Do you get half of it?
Yeah.
Okay, so if you go to window, you have a T-min and a T-max. So is your T-min set at 0? Okay, so try setting it at, what did we use here? -2? Like if you set it to -2 and then 3 and then graph it, you'll get exactly what we just graphed. Okay? When you hit zoom 6, it'll go back to its normal self. So hit zoom 6 and it'll go back to starting at 0. Zoom 6 sets it back to its standard stuff.
Do we want it at 0?
Well, maybe you want your next one at 0. I don't know. I don't know how often you'll actually get to use this, but I want you to be able to understand how your calculator works. So, oftentimes when we talk about parametric equations, if we get into a realistic setting, t is time, and we want time to start where? 0, which is why your calculator is set that way. But if we're just talking about an equation, we might want it to start earlier than t is 0. Okay, so you'd be able to change that. Where do you change it at? Window, the T-min, T-max is what you would be able to change.
Where does the T-max do?
That's where it would stop plugging in T. So like I changed it -2 to 3 because that was our interval, and that's the graph that it gave. Okay. Okay. Well, let's do another one. Go ahead and write this set of parametric equations down. Okay, well, this one isn't telling us where to start. How will we know where to begin our chart?
Yes.
Do you think we could make,
-2 to 2.
do you want to plug -2 in for t?
No, I don't put a 0 in there.
Why would we put 0 in there, guy?
That's where the time starts. Also, it's just easy. And there's a graph.
There's a better reason for why 0 should be where we start. X is radical t. Can we plug negative values in for radical t? We don't want imaginary numbers, okay? So the first number we can plug in to x equals radical t would be t equals 0. And what do we get when we do that? We get 0, 2, right? Okay? And then if we plug in t equals 1, we would get square root of 1 and 1 plus 2. Okay? Now, I'm going to make my life a little bit easier. I don't really want to plug in 2, and I don't really want to plug in 3, because I don't really want to plot radicals. But plugging in 4 would be nice, right, Max?
Yeah.
Because then we get the square root of 4 and 4 plus 2. Okay? What is this creating? Yes. Well, we have two separate equations. When we plug in t, we're getting an x coordinate and a y coordinate, and that is creating a point. Well, t is right, which creates the graph. Right. Yeah. What is this starting to draw? What does it look like?
It's like
Half of a parabola. But only half of a parabola, right? We couldn't plug in anything over here because we can't plug negative values in for t since it's under the radical. Okay, now, do you really want to go through a bunch of equations trying to figure out which t's you should plug in and which t's make it nice to plug in and plotting those points and connecting your graph? Kind of seems like a lot of guesswork, right? I mean, the two examples I gave you were nice, but what if I give you y equals x squared or y equals t squared and x equals t plus 2? How will you know where to begin? Okay? So I would like to teach you how to take your two parametric equations and squish them together to be the one rectangular equation. And that's what we're going to call eliminate the parameter. Okay. We're going to eliminate the parameter. What did I call the parameter? What's the parameter? T. T is our parameter. So when I say eliminate the parameter, let's get rid of that third variable and make it only one equation instead of two separate ones. Okay? So, here are our steps. 1. Solve for t in one equation. Step 2. Substitute into the other equation. Essentially we have two equations with the same unknown. Solve for one, throw it into the other, and then make it look pretty. Okay, simplify it. Whether it's some sort of like quadratic and solving for y would look nice, or maybe it's some sort of conic and you know the standard form of a conic. Okay? So let's go to this right here. Does this look familiar?
Yeah.
It's like the first one we did, but without that interval. So go ahead and rewrite it down. We're going to eliminate this parameter. Out of the two equations, if we were to pick one to solve for t, which one might be the easiest to solve? X or y? How about you talk about at your pod? Pick which one and why. Then you ate y.
Yeah.
Well, it's just boring.
Okay, let's make a vote. Who wants to solve for t and x? Who wants to solve for t and y? Okay, Emily, what's your reasoning for y?
Because you just have to multiply the 2 over and then like t's already solved.
So 2y equals t. Okay. As I was walking around, I heard some people say, well, both are pretty easy. I agree, but what's going to be the trouble with x? Square root, and when you square root both sides, we have plus or minus. You don't want to deal with plus or minus. Okay? So t would equal 2y, which means we have x equals 2y, the quantity squared, minus 4. Okay, so if we wanted this to be in the standard form of our parabolas, we would have x plus 4 equals 4y squared, but we always want the coefficient with the linear term. So we would have 1/4 the quantity x plus 4 equals y squared. That would be the equation of our parabola. We know how to graph that. Okay. We know that our vertex is at -4, 0.
Does the 4 do it again? Like make it a 1?
No, because if it was distributed, yes. But we're going to keep it out so we can tell where the vertex is. Okay. So is everyone okay with this standard form equation? I kind of jumped into the graph. I got excited. Is there anything that we want to talk about here? Okay. So we know that the vertex is -4, 0. And we know that it is a parabola that looks like this, right? Well, the difference here is we actually have to indicate the orientation. How are you going to figure out where the arrows go? Okay. My suggestion to you would be to pick a couple t values up here to plug in. Okay. T is 0 gave us this point. T is 1 gives us this point. And so I know that our arrows would have to go in this direction. Okay. So you still need the parametric equations to figure out what your orientation is. Pick an easy one, t is 0. Pick the next one, t is 1 or 2 or whatever, and figure out the path that your graph is taking. Okay. Questions before we do another one? Okay, let's go back to this one right here. I want to eliminate the parameter for this guy. X equals square root of t and y equals t plus 2. It's not that much work. I promise you. Okay, so if we eliminate the parameter, take another vote. Which one do you want to solve for, X or T? Talk about it at your pile. 30 seconds. Okay, who votes X? Who votes Y? Okay, 6 one way, half a dozen another. Okay? Those of you who wanted to solve for it in the X equation, X squared equals T. Right? So then Y equals T plus 2. Those of you who wanted to solve for y, you would have gotten the exact same thing, but actually it would have taken a few more steps. Okay? Does it matter? Not at all. Okay? However, this looks like a parabola to me, right? Well, we only graphed this. Okay? When you have a radical in your parametric equation set, you do need to consider how that would affect the domain. So, we know that t needs to be greater than or equal to 0. When we plug in t equals 0, we end up getting x equals 0. And our x's got bigger. So we would need to say, as a part of our equation, that yes, we have this y equals x squared plus 2. We have this parabola, but it's only for x is greater than or equal to 0 based on the domain of our parametric equation set. Okay? So if there's any sort of square root in your parametric equation, you do need to consider how that would affect the domain of when you eliminate the parameter. All right, 2 more examples, at least as a class. Go ahead and write this down. Okay, before we eliminate the parameter, are there any domain restrictions this would have in terms of t? Are there any t values that aren't okay? Okay, we don't want to divide by 0, so we know that t cannot equal 1 if we were talking about the domain of our parametric equation set. Okay, well now let's eliminate the parameter. Can we all agree that solving for t and x is going to be simpler? I don't think we want to even touch the y. Okay? So if we were to eliminate the parameter, we could write that t equals x plus 1. Do you agree? Okay? So then y would equal t over t minus 1. Well, let's go ahead and simplify this here. Our denominator would really just be x. Okay. In our parametric equations, t could not equal 1. If we plug 1 in for t, what does that correlate with for x? When t is 1, x is? So in our rectangular equation, we would need to indicate that x cannot equal 0, which makes sense with the equation that we just wrote. Let's just review how to graph a rational equation. Our denominator is 0 at x equals 0. Therefore, we have a vertical asymptote. Remember that? The degrees of our numerator and denominator are the same, which means we look at our coefficients. We have 1 over 1. So y equals 1 is our horizontal asymptote. Okay, so there's our graph, and and then we would just need to indicate the orientation with those arrows. Okay, how do you figure out the direction that it goes? Plug in t values. If you plug in t equals 2, and then you plug in t equals 3, you get a coordinate here, you get a coordinate here. So t equals 2, t equals 3. I know that we need to connect those with an arrow facing that direction. All right. I said the word conic before. I guess we have had a parabola. But one last example. Ooh, it looks a little different. What's our parameter now? Theta. Well, theta is just the Greek t, so, you know, it's still a t. But when trigonometry is involved with our parametric equations, often you'll see theta instead of t. Don't panic, it's still the same thing. Okay? But how do we eliminate our parameter? Okay, don't write anything down, but if I solve for theta in x, I would have x over 3 equals cosine of theta. So the inverse cosine of x over 3 equals theta, and you want me to plug that in?
Yeah, that's so funny.
Let's do it.
I can't do that.
But I like this, x over 3 equals cosine. I do. And we could do the same thing over here, y over 4 equals the sine of theta. No, it's really too bad we don't have an identity that relates cosine and sine together.
Oh, yeah.
What is it, Max?
It's that one tangent.
Well, I don't see a tangent up there. I just see sine and cosine. But that equals tangent. I don't want tangent. I want an identity that only has sine and cosine.
Equal 1 if we square them. Oh, those
It equals 1 if you square them both. Yes, you are right, Dallas. Sine squared plus cosine squared equals 1. Do you remember that?
Yeah.
Okay. But you guys are like freaking out. Watch. Cosine of theta is x over 3. Okay. The sine of theta is y over 4.
Okay, well that's
What do we have?
That's
We have an ellipse. X squared over 9
fun.
plus y squared over 16 equals 1. Okay, well I know that it looks like this, but we also need those arrows. We need to know the orientation, right?
Right.
Yeah. Okay. Well, if I plug in 0 to our parametric equations up here, what's the cosine of 0? So we have x equals 3 and y equals, if I plug in 0, y would equal, okay, so that's here. Theta equals 0. If I plug in a nice one like pi over 2, if I plug in pi over 2, what does that make x? Yeah. So 0, right?
Yeah.
If we plug in pi over 2 here, what do we get? 4. So 0, 4, oh, that's right here. So our orientation would be that. Okay, so in your homework, you're going to have some problems I ask you to graph. by making an XY chart. You're gonna have some problems. I ask you to eliminate the parameter and then graph. So that's it. That's all your homework is. Please pay attention to when they ask you to use your calculator and when they don't. Okay, I don't want you to use your calculator unless it specifically asks you, but it could, so be ready for that.
What? Yeah.
Yeah, Max, we also put mine up there and then grab my calculator.
Only if you toss it.
So I have a couple more calculators up here that I need.
Okay.
Could somebody please tell me